In this video, we are going to talk about Terraform. First, I'm going to explain to you what Terraform is and what it's used for. Then we will see what is difference between Terraform and Injable and when to use each. We will also look at the Terraform architecture and command, as well as an example Terraform configuration file, after which you will have a good overview and understanding of how Terraform actually works and how it does its job. So first of all, what is Terraform? Terraform allows you to automate and manage your infrastructure and your platform and services that run on that infrastructure. It's open source and it uses the clarity of language, meaning you don't have to define every step of how this automation and management isn't done. You just clear what you want, the final result or end result, and Terraform will figure out how to execute its versus imperative style where you specify how to execute each step. So as I said, Terraform is a tool for infrastructure provisioning. So what does it mean exactly? Let's say you just started a project where you create some application and you wanted to set up an infrastructure from scratch where this application will run. How does your infrastructure look like? Let's say you wanted to spin up several servers where you will deploy your 5 microservices applications that make up your application as Docker containers. And also you are going to deploy a database container. You decide to use AWS platform to build your whole infrastructure, and so first step will be to go to AWS and prepare the setup so the application can be deployed there. This means you create your private network space, you create an employee server, in situ server instances, you install Docker on each one of those, plus any other tools that you might need for your application. You set up security on your servers like firewalls, you set up network, etc. Once the infrastructure is prepared, you can now deploy your Docker applications and Docker containers on that prepared infrastructure. So as you see, these are two different tasks, are two separate steps of creating the whole setup. One is provisioning the infrastructure, preparing everything so the application can be deployed. The second one is actually deploying the applications on it. So you might have two separate teams or two individuals who do these two separate tasks. So a possible scenario, DevOps team member configures the infrastructure and a developer then deploys the application on prepared infrastructure. So where does Terraform come into this whole thing? Terraform is used for the first part where you provision the infrastructure to prepare it for the application deployment. Creating the EPC, spinning up the servers, creating the security, the AWS users with its permissions may be installing Docker, specific version on servers, etc. And obviously all of this need to be done in a correct order because one task maybe depends on the other. Now here I must mention something that a lot of people ask when it comes to Terraform, and that is what is the difference between Ansible and Terraform. Because they seem to be doing the same thing, especially if you read the official definition or official documentation, they sound like the same tool. So the question is pretty logical. What is the difference between them and which one should I use for my project? So let's say the similarities and differences between these two using our examples. First of all, Terraform and Ansible are both infrastructure as a code, meaning they are both used to automate provisioning, configuring, and meaning the infrastructure. However, Terraform is mainly infrastructure provisioning tool. That's where its main power lies. But it also has possibility to deploy applications in other tools on that infrastructure. Ansible on the other hand is mainly a configuration tool. So once the infrastructure is provisioned and it's there, Ansible can now be used to configure it and deploy applications, install and update softwares on that infrastructure, etc. So as you see there, overlaps of what each tool does, and this creates the confusion. Other differences to consider in terms of those overlaps are Ansible is more mature and Terraform is relatively new, and because of that is also changing dynamically, and Terraform is much more advanced in orchestration. So to summarize the difference, Terraform is a better tool for provisioning infrastructure, and Ansible is a better tool for configuring that infrastructure, deploying, installing applications and services on them. So it's a common practice where DevOps engineers use the combination of these tools to cover the whole setup end to end using both for their own strengths. instead of just using one tool. Now if you wanted to learn more about Ansible, as well as I have one video that I made about it where I explain exactly what Ansible is and how to use it, so you can check out it. And I also create another video where I will compare the infrastructure is a code tools like Ansible, Chef, Terraforms, Cloud Information, etc. in more details, and also explain why each is best in one area, even though they can do other tasks as well. So if you wanted to see those videos and if you wanted to learn more, then you can subscribe to my channel, you can click the notification bell and stay tuned for upcoming videos as well. So now let's go back to our use case where we created the infrastructure using Terraform and on AWS provision successfully for your project and your deployed application on it. Now we decided that you wanted to add 5 more servers to the existing infrastructure to deploy more microservices because your team developed some more features and they needed to develop it, and you also wanted to add some security configuration or maybe remove some stuff that you configure at the beginning. So now we are in the phase of managing the existing infrastructure, adding some stuff, reconfiguring, removing some stuff, etc. And using Terraform, you can make such adjustments to infrastructure pretty easily, and this task of managing the infrastructure is just as important because you have created the initial infrastructure for your project. You will be continually adjusting and changing it, and because of that you also need some automation tool that will do most of the heavy lifting for you so that you don't have to manually configure and do some stuff. So once you are set up with Terraform to create and change or maintain your infrastructure, another useful thing or a common use case would be replicating that infrastructure. Let's say after you tested this setup and everything works fine, you decided now you wanted to release your application in production environments. So you wanted to create a production environment that replicates this exact setup and keep the first as a development environment where you can test a few features, new microservices and updates before you launch it into production again. You can also Terraform here to automate that process, so you can easily spin up an identical infrastructure and set up using the same traffic run code that you use for the first setup, the development environment setup. And you can do the same to speed up at identical stacking servers as well. So that makes these tasks also very easy. So how does Terraform do all this? How does their firm actually connect to these infrastructure provider platforms and use all these technologies to provision stuff? So for example, how does Terraform connect to AWS to create virtual space, start EC2 instances, configure networking, etc.? In order to do the job, Terraform has 2 main components that makes up its architecture. The first one is telephone core, and the core uses 2 input sources in order to do its job. So we take cell phone configuration that you use as a user, right? And where you defined what needs to be created or provisioned. And the second one is there from the state where Terraform keeps up to date state of how the current setup of the infrastructure looks like. So what core then does it take this input and figures out the plan of what needs to be done. So it compares the state, what is the current state, what is the configuration that you desire the end result as I mentioned at the beginning, and compares that when it sees there is a difference, so you want something else, then what the current state is, it figures out what needs to be done to get the desired state in the configuration file. So what needs to be created, what needs to be updated, deleted, in which order on that infrastructure setup. And the second component or the second part of the architecture are providers for specific technologies. This could be cloud providers like AWS measures or other infrastructure as a service platform. So for the infrastructure level tasks, but Terraform as I mentioned is also provides for more high component like Kubernetes or other platform as a service tools. Even some software is a self-service tool. So it gives you possibility to create stuff on different levels, like create a AWS infrastructure, then deploy, or create Kubernetes on top of it, and then create services inside that or components inside that Kubernetes cluster. So it gives you all these possibilities, and it does that through those providers. Terraform has over 100 providers for these different technologies, and each provider then gives Terraform user access to its resources. So through AWS providers, for example, you have access to hundreds of AWS resources like its 2 instances, the AWS users, etc. With Kubernetes provider, you have access to the commodities resources like services and deployments and namespaces, etc. So this is how this works, and this way Terraform tries to help you provision and cover the complete application setup from infrastructure all the way to the application, and this is your convenient. But as I mentioned in the comparison between Terraform and Ansible, Terraform's strength is actually in the infrastructure provisioning, and for the other stuff you can use Ansible or similar tools. So once the core creates an execution plan based on the input from config file and state it, then uses providers for specific technologies to execute the plan, to connect to those platforms, and to actually carry out those execution steps. So now to also have an idea of how Terraform configuration file looks like, this is an example where you see AWS provider is configured, and through the provider you now have 2 AWS resources like VPC. You can create that with some attributes. The same way you have the Kubernetes provider here configured, and through that now you can create a Kubernetes namespace resource where you pass some attributes, and the syntax is very intuitive. I would say basically define what she wants you, what a resource of a certain technology or certain provider created, and then you define its attributes, and that's what Terraform will create or do for you. Now one thing I mentioned the beginning and I wanted to go into detail is the declarative approach that Terraform's configuration files are written in, and this is important to understand. So what does declarative mean exactly? When you create a Terraform file, instead of defining what steps to be executed to create a BBC or to spin up 5 EC2 instances or create the network configuration, you define the end state you desire. So you say, I want 5 servers with network configuration like this, and I one AWS user that has these permissions to access all the servers. Terraform go do that for me. So instead of defining exactly what to do, which is an imperative approach, you define what the end result should be, a declarative approach. Now for the initial setup, this may not take much differences. So when is the configuration of imperative and declarative approach, it might actually look pretty similar. But consider when you are updating your infrastructure, like removing a server or adding another server or making other adjustments with imperative approach, you would say in a configuration file, remove 2 servers, add a firewall configuration and some permissions to the AWS user, etc. So you give instructions of what to do with the clarity of approach. Like in Terraform example, you would say my new desired state is now 7 servers, this firewall configuration, and users with this set of permissions do whatever needs to be done to get from the current state to the new desired state. So now you don't need to actually calculate and decide how many services needs to be added. You say I want 7 servers at the end, that's what I want, or you don't need to calculate and figure out how many permissions or which permissions you should add. You just say what this set of permissions to come out at the end. So with the declarative approach, if you just adjust the old configuration file and re-execute it instead of adding the new set of instructions, this is obviously very comfortable because your configuration file stays clean and small, but also you always know what the current setup is just by looking at the configuration file, because that's always the end result. Whereas in the first approach, an imperative, you have to somehow add this up and figure out the delta between all the changes applied by multiple instructions. So you have created the Terraform file, configuration file that defines your desired infrastructure setup on AWS. Now how do you make Terraform take action? Terraform has commands you can execute to go through different stages, which is pretty clear and straightforward. And the first command is refresh. With this command, Terraform will query the infrastructure provider, in our case AWS, to get the up-to-date state. So Terraform will know now what is the current state of the infrastructure. The next command is plan. Remember I said the core is responsible for taking current state in your configuration file, is input and decide based on the difference what needs to be done. That's the plan. So what Terraform needs to do in order to achieve that desired state, that you defined in a Terraform configuration file. If it's an initial setup, it figures out all the steps to create the desired setup. If it's an update, it compares the existing setup with a new desired state and figures out what changes and adjustments needs to be made in which order to create a new desired state. For example, at a new server and a new permission, etc. Now, this is just a plan. This is where the core kind of constructs the plane logically or what needs to be done. The next command is the command where the actual execution happens, and that's the apply command. So we would apply, you can execute the plan. So plan command is like a preview of what's gonna happen if you execute apply. Obviously Terraform in the background will do the refresh at the up-to-date state, then create the plan and then apply it. Which means if you wanted to execute a configuration file, you can just execute the apply command and it will do all this, and other command is destroy, which obviously destroy the whole setup, removing elements one by one in the right order and cleaning up all the resources that were created, basically reverting everything that has been created, and this could be used. If let's say you create an environment for an important demo and you didn't want to interfere with the existing environments, once the demo is over, you can destroy the whole setup. Destroy like apply will also check what's currently running and then create a plan of what needs to be removed in which order. So I hope this gives you a good high level overview of Terraform and how it works. If you wanted to learn much more stuff, then subscribe to my channel and stay tuned for more videos like this. Thanks for watching. See you in the next video.